Okay, hello and welcome to the beginning stages of Miss Cooper's college algebra class, where we're actually going to be going over some of your prerequisite skills. So notice I'm calling these prerequisite skills, things that you should have probably mastered in levels before, maybe should have been exposed to in, say, intermediate algebra or beginning algebra. So really just want to take some time to level the playing field, make sure we're all comfortable, okay? So let's start off the skill sets that are, I'm going to go through this practice set with you, and like I said, I might go through it kind of quickly, so you really have to, self-diagnose and, see where your areas of strength and weakness are. Number one, identify the equation as an identity, an inconsistent equation, or a conditional equation. My first thing I want to say is if you have no idea what that language means, like what is an identity or an inconsistent equation, don't worry about that right now. Let's just focus on solving it. So I'm actually going to scoot this over here, and I'm going to re-record the equation here. So let's see if it'll let me do that. Okay, so I'm just going to rewrite it here for you guys so you can see it a little bigger. So 4 times 4g minus 4, and then minus 16g plus 16 equals 0. Okay, so that's the first one. So let's say you go to solve it, right? And you have 16g minus 16 minus 16g plus 16 equals 0. You keep cleaning, combine the like terms, the g terms cancel out. Negative 16 plus 16, these cancel out as well. So you're ending up with 0 equals 0. Aha! But 0 equals 0 is not a false statement. It's a true statement. In fact, it's an identity. So now, let me scoot this back on over. Now you know the answer. It's an identity. Therefore, the solution set is all reals. Now, a lot of people ask me, what should I put on the test? Should I say it's an identity? Well, that's the classification, but the actual solution set, I should reiterate, is all reals. That just means that any real number in the whole world will satisfy the original equation because the original equation is an identity. Okay? Now, for the next one, number 2, notice that there's a lot of fractions in there. So I want to remind you on sort of tactics for getting rid of fractions. So I'm going to hit pause as I erase that whiteboard. Okay, so I'm just, rewriting number 2 for you over here. So for number 2, we're going to have, 2/5 x plus 1/4 equals x over 10 plus 1/8. And just remember that if you want to solve, and we're told to solve the equation, if you want to solve an equation that has a lot of fractions in it like that, your best bet is to draw giant brackets around the whole thing. Pick the LCD, least common denominator, for all the denominators, okay? And you say, what number do they all go into? So maybe you're thinking 40. All right, so let's take 40, and all you do is you take 40 and you send it through via multiplication, multiply, to the numerators only. That's big, numerators only. So I'll talk you through. So 40 times 1 is 40, but 40 on top of 8, and if you need to write that, write it. 40 on top of 8, or 40 divided by 8 is 5. So what's going to happen is those fractions are going to clear. You're going to end up with 5. Let's keep doing that. 40 times x is 40x, but 40x on top of 10 is going to send you right back to 4x, right? So we're clearing those fractions. Try again. 40 times 1 is 40, but divided by 4, or on top of 4, is going to send you right back to 10. And we try one more time. 40 times this 2 here is 80. But 80 on top of 5 is what? Or 80 divided by 5 is what? And hopefully you're thinking 16. And there's an x there, don't forget the x, 16x. Okay, when you arrive here, we're happy. Why are we happy? Fractions are gone, easier to deal with. Okay, so now let's move 4x to the other side. Okay, now we have, 12x plus 10 equals 5. Now just move 10 to the other side. Let's see if I can zoom here. Move 10 to the other side, meaning subtract it off. You know, balance the equation. You guys are good at that by now because you've been through many levels of math. So you arrive at 12x equals, and I don't think I have, oh maybe I do. Let me hit pause here so I can extend this page. Actually, I just realized I don't have infinite extent on this paper here, so I'm just going to kind of rewrite it over here. Oops, I hope it puts it back. Well, unfortunately, it just took away my drawing. I'm not sure why it did that. But we were at the stage where we had 12x equals, okay, so we were at the stage, and I recorded the step above it, where we were at 12x equals -5. So then you just divide both sides by 12, and you're arriving at -5/12. Now you'll notice stylistically, maybe I can zoom in here. Sometimes I'm afraid to mess with this app because if something disappears, but you're noticing stylistically that the answer is in curly braces. So a lot of people say, hey, should I put my final answer in set builder notation? It's nice. Yes, it's nice to do that, and I think sometimes the online homework requires you to do that. Okay, I'm just going to keep cruising. You can hit pause if you get stuck, but I'm going to keep cruising through these. Okay, let's try number 3. I'm going to erase my whiteboard. Okay, so I've recorded number 3 over here, and again the command was just to solve the equation, so we're just going to go ahead and solve this. Now if you're thinking, wow, this is just beginning algebra, that's right, we're just kind of bringing the memories back. So now we've got 8z minus 8 for starters. The course will get complicated enough in about a week or so. So 8z minus 8 equals 7z plus 21. Okay? I always say letters on the left, numbers on the right. So you want to bring 7z across the equal sign, but you can't just throw it across the equal sign. So you're going to negate it, right? Subtract it. So 8z minus 7z is 1z. And here I want to add 8 to the other side. So we're arriving at 1z equals 29. That means the same thing as z equals 29. So survey says here. Okay. Now see, already in the next problem we get a little bit deeper. Notice number 4 is a rational equation. It still wants, oh, I forgot to mention this language. If you get a solution, like if you get 1 or 2 or 3, a discrete amount of solutions that satisfy the equation, such as we did in number 3. So number 3 would be conditional. It doesn't ask us, but, and number 2 was also conditional, right? Because we actually found an answer. You know, number 1 was an identity. Here they're starting to ask us the same thing. Is it, you know, an identity, inconsistent? Inconsistent means basically you have no solution. An identity means all reals is your solution set. So, okay, I'm going to rewrite this one. Now this is going to be a bit tricky because I hope I actually have enough room to do this, but this is what's called a rational equation, and if you need to solve something like this, you're going to need to identify the LCD for starters. So you're going to want to factor the denominators. So first I'm going to pull the GCF out of here, and I see 2 times x plus 1. Then I'm going to pull the GCF out of here. If you forgot what a GCF is, it's the greatest common factor, so I'm going to factor out the GCF. And now I'm trying to spot the LCD, so let me do this in another color, purple. Okay, x plus 1, x plus 1, x plus 1. Aha! I see all the fractions have an x plus 1 in it. And then I always say, why don't you invoke the doo-doo rule? It's not a real rule, I call it the doo-doo rule. Meaning, give each fraction what it's lacking to get to the LCD. So, kind of like this. He's got an x plus 1, so does he. He's got a 2, well, he's got a 4. So, he needs a 2 to get to have as many as the other fraction had in the denominator, right? So it's kind of like, all right, let's multiply this 1 by 2. So I'm just going to write here, I kind of don't have a lot of room, but I'm going to write multiply by 2. But whatever you do to the bottom, you got to do to the top. That's why I call it the doo-doo rule. To keep it legal, you got to do that. So long story short, what I'm saying is the LCD is this 4 times x plus 1. So you have to give the other fractions what they're lacking. For example, over here, he's got an x plus 1, but what's he lacking? He's lacking a 4. So give him a 4. But whatever you do to the bottom, you got to do to the top. Okay, now the catch. Every single fraction now has the LCD. LCD, LCD, LCD. Once you've given them all the LCD, then you no longer have to worry about the bottoms, is what basically happens. And you focus in only on the top. And that's what becomes your equation. So tell me what I did. 2x equals negative 2x plus 4 times the quantity 2x minus 3. Aha! Maybe you're noticing that all I did was grab the numerators and let that be my equation that I need to solve, because the bottoms have already been equated, so you can focus on the tops, the numerators. Okay? Keep cleaning. That's going to be 8x minus 12. Here you've got negative 2x plus that equals 2x. I always say, combine your like terms, so negative 2x plus 8x is 6x. So now we have 6x minus 12, and then over here equals 2x. And then, as I knew, I was going to run out of room with this problem, so I'm going to see if I can maybe squeeze some of it over here. See if it'll let me erase some stuff over here, and I'm just going to write on top of it. So when you're at the moment of 2x equals 6x minus 12, just move 6x to the other side, subtract it off. So you'll have negative 4x equals negative 12. Therefore, x must equal whatever negative 12 divided by negative 4 is, which is 3. Okay, so I had to write on top of my worksheet there to get x equals 3, but let me go back and see the answer key. So we're claiming x equals 3. Let's take a look. Survey says, aha, there it is. We claimed x equals 3, yep. So x equals 3 is conditional. The only way to know that, you're right is to, take 3 and throw it back into the original and see if it balances out. Okay. Now let's try the next one, number 5. I'll write it over here on the white board. Okay, so again, we have another rational equation. So now you're getting warmed up to those, and you know that in order to solve this, you have to factor and identify the LCD. So this will factor into x plus 7 and x plus 4. I'm assuming that you kind of know how to factor because you're at this level of math, so you had prior levels, so you know how to factor this trinomial. Okay. Now you're also noticing that, hey, this has an x plus 7, this has an x plus 4, so hey, this is the LCD, right? So we talked about giving the other fractions what they're lacking, so I'm going to do this in another color, maybe dark red here. Okay, so he needs an x plus 4, so give him an x plus 4. If you do to the bottom, though, you got to do to the top. And the 3 needs an x plus 7. Do to the top, do to the bottom. And this guy, this negative 3, already has the LCD underneath it, so he doesn't need anything. So now what you've done is you've given this fraction the LCD, you've given this fraction the LCD, and this fraction already has the LCD. So they all have the same denominators, and now you remember what happens. In order to solve the equation, now we're going to ignore the denominators, basically, and we're going to grab the numerators. So now we're going to grab the x plus 4 plus the 3 times the x plus 7 equals the negative 3, and that's going to be our equation. So once you've laid that construction where the denominators are the same, focus in on the numerators and go ahead and solve. Alright, so then we'll have, x plus 4 plus 3x plus 21 equals negative 3. Go ahead and combine your like terms. So I'm just going to move this over here since I'm running out of room. So I'll have 4x, like terms, is this x, and 3x makes 4x. 4 plus 21 makes 25 equals negative 3. Move 25 to the other side. Now this is going to get interesting. You arrive at 4x equals negative 28, so you're feeling like x equals negative 7, right? But aha, x cannot equal negative 7. The final answer is no solution. How come? Now I'm going to zoom in on this part of the worksheet over here. X equals negative 7. Let's take a look. Eyeball it back into the original. X cannot equal negative 7 because negative 7 plus 7 will cause a 0 in the denominator of that fraction right there. I don't know if you can see that because I put my pen mark over it. But x cannot equal negative 7. So therefore, what's the final answer here? So a lot of people will accidentally guess and think it's D, but it's not. It's A, right? Inconsistent, empty set. So, long story short, the answer to 5 is going to be A, no solution. That means it's an inconsistent equation. How come? Because we got to -7, but it's going to cause the original to be undefined. So big thing, when you're looking at a rational equation, big note to self, make sure you eyeball. Make sure you eyeball the solutions. What do I mean by that? You know, check the original to see that you're not ending up with something that's going to cause the original to be undefined. Okay? Let's try the next one. Okay, so I realize I wrote this a little crooked. It's like on a slant. But looks like here we're just solving a basic equation. Let's see if anything weird happens. So 25k plus 77 equals 25k plus whatever 5 times 14 is, which is 70, right? So let's say, some of you notice it already, but let's say you keep going and you solve this. Uh-oh, you're going to end up with 77 equals 70. That doesn't make any kind of sense. So what does that mean? It means inconsistent. Inconsistent. Means the equation's inconsistent, which basically means there's no solution. This symbol here is the empty set. Means the set that contains nothing. So there is no solution. So therefore, if we look back at number 6, we know the answer is B. Okay? All right, and last but not least, I think I actually have room to do number 7 right here, right underneath it on the page. So it's an absolute value problem. So recall the recipe for solving absolute value, and I'm going to write that here. Isolate the bars, the absolute value bars, and make 2 cases. That's the general recipe if you're looking for a recipe. Alright, so what does that mean? That means we're going to have to take -9 and toss it across the equal sign. You can't just toss it, it means add it, right? So 2 bar x plus 4, n bar. If you add 9 to the other side, you're going to have equals 1 plus 9. Okay? So at that moment, you know, you have 2 bar x plus 4 equals 10. You cannot distribute that 2. Whatever you do, don't distribute that 2 through the bars. What are you going to do? You're going to divide by 2. Because you want to get those bars isolated. Isolate the bars. That's phase 1 of the game. Okay? So I'm going to erase this part. Okay, so now we got the bars isolated. Life is good. So we have x plus 4, you know, equals 5. Because 10 divided by 2 here is 5. And it's still in bars. But then the recipe said, in order to remove the bars, you would have to make 2 cases. Well, what are the 2 cases? Well, either x plus 4 equals 5, or x plus 4, I'm going to separate it here, x plus 4 equals -5. So basically the 2 cases are, you know, whatever's in the bars equals the constant, or whatever's inside of the bars equals the negation of the constant, the opposite of the constant. Okay? We go ahead and subtract off the 4. We're going to get x equals 1 as one possible solution, so I'm just going to record that, x equals 1, or here if I move 4 to the other side, I'm going to get, oops, if I move 4 to the other side, I'm going to get x equals -9. So notice 1 or -9. Notice, big note to self, 2 solutions. Aha, so there's 2 possible numbers in the whole world that satisfy that. And you can check, I mean, store -9 into the original, right? -9 plus 4 is -5, but the absolute value of -5 is 5, and 5 times 2 is 10, and 10 minus 9 is 1. So it does check out. But the biggest thing that I can say, and I'm going to put this here in another color, two cases. You must set up this case and this case. Don't forget to make 2 cases when you're dealing with absolute value. All right, I think we're finally ready to head into the word problems. So I wanted to talk stylistically. I don't like my podcast to go too long, so I wanted to talk about this worksheet. So notice numbers 8 all the way, so you can just kind of see this with me. Numbers 8 all the way to 13 are word problems. So I'm going to do a separate podcast for the word problems. And then after that, numbers 14 all the way down to the end, to 21, have to do with graphing. So these are different skill sets. Word problems is one skill set. Graphing is a total another skill set. So I'm going to be doing this in 3 different podcasts. All right, good luck.